Since its launch, the Rosetta mission has made a remarkable journey to find out more about our solar system by studying a comet's nucleus, coma, and tails. The journey required 3 gravitational assists from the Earth and 1 from Mars. Along the way, it studied asteroids Steins and Lutetia, before heading into deep space and temporary hibernation in 2011. After 10 years in space, ESA's European Space Operations Centre in Germany needed a crucial signal to let the world know that Rosetta had woken up and was ready to meet a comet. The main science mission got underway, with many of the 11 orbiter instruments reactivating and preparing for action. A series of rendezvous manoeuvres brought Rosetta towards the comet. And as Rosetta got closer, the true shape of the comet revealed itself. Within months of waking up, the MIRO instrument made the first observations of water vapour streaming away from the comet, equivalent to 2 small glasses of water every second. The Virtus instrument provided the first temperature measurements of the surface of the comet, around -70 degrees C, indicating the comet has a dark, dusty surface. Arriving at its destination was another crucial stage. 2 large and 6 smaller thruster burns gradually reduced the spacecraft's speed so that it could become the first spacecraft to orbit a comet. The following weeks focused on global mapping to select a landing site. At the same time, Rosetta made its first scientific analysis of the comet. Measurements of the comet's mass and volume revealed it to be highly porous, and the unusually dark surface revealed 5 diverse types of terrain, ranging from surfaces that are smooth or covered in dust to brittle materials showing pits and circular structures, large-scale depressions, or more rock-like structures. Rosetta's Rosetta instrument detected gases from the comet, including carbon monoxide, methane, ammonia, methanol, and carbon dioxide. The variation in amounts of these gases in different parts of the coma suggests a complex relationship between it and the comet nucleus. After the rendezvous, the primary landing site for Rosetta's Philae lander was selected from 5 shortlisted sites. No other mission had attempted to land on a comet before. After Rosetta released its lander, Philae underwent a 7-hour descent and landed on the comet. Rosetta's navcam captured Philae's dust cloud on landing, and within hours Philae sent the first image of a comet from a comet's surface and the first panorama. The landing, however, produced some surprises. Philae didn't secure itself to the comet's surface and bounced, making multiple touchdowns. The final resting site was partly in shadow, receiving less sunlight to recharge its instruments. In a race against time, the 10 lander instruments went to work. But after nearly 57 hours, the data was returned, and Philae completed its primary science mission and went into hibernation. Rosetta has discovered that the ratio of 2 different forms of hydrogen in the comet's water is different to that on Earth, more than 3 times higher. The findings suggest a much weaker connection between comets and the Earth's water, and more emphasis on asteroids. Rosetta also detected molecular nitrogen, thought to be the most common type of nitrogen when the solar system formed, and the first time it has been found at a comet. Together with measurements of hydrogen isotopes, this suggests that the comet is a very ancient one and provides us with insight into its formation conditions. Together, Rosetta and Philae made the first detailed investigations of the magnetic properties of a comet nucleus, helped by the lander's multiple contact points on landing. They found that the comet isn't magnetised, suggesting that magnetic forces are unlikely to have played a role accumulating building blocks of planets that are 1 metre or larger. Rosetta is answering questions about our solar system and will continue its mission until the end of the year. The scientific adventure continues.